Hello everyone, welcome to Helm of Science. So in today's video, we shall be discussing about some common questions that have been asked in the last 10 years of joint entrance examination from the chapter Electrochemistry. So now it is not possible to discuss all of the questions that have come. So I have chosen a very few selective questions with the motive that it will help you to understand the concept and have a better approach towards the questions. So I hope this video will be helpful for you guys and it will help you get a better score in the upcoming examinations. Without wasting any more time, let us just get straight away into the video. So before starting with the first question, let me just read out the first question. The first question says, the reduction potential of the electrode H plus to H2 at P atmospheric pressure using a platinum electrode is given by the relation, and there are four options mentioned as A, B, C and D. Now, how would we start off the answer? So let us see. See, the cell equation mentioned to all of you, or the half cell equation to be precise, is mentioned as, just a second. Okay, it's mentioned as H plus 2 H2 gas and with platinum electrode. That's right. So first let us write down the cell equation, half cell equation. So the half cell equation says H plus 2 H2 gas at P atmospheric pressure in the presence of platinum electrode. You have to write down the reduction potential expression for this electrode. Now we know that using Nernst equation, E cell is referred to as E0 cell minus 2.303 RT by NF log of product by reactant, or if I have to be a little more precise, it should be concentration of product by concentration of reactant. That's right. Now if you check the options, first thing that you will see that it is written ln in place of log. So the first thing that should come into your mind is, if we have to change ln to log, we have to multiply ln with 2.303 in order to get log, right? So since it is written as ln, so we will not use this factor 2.303. So this factor won't be there. So the expression reduces to or changes to E cell equal to E0 cell minus RT by NF ln of product by reactant. Right, students? Now, another thing you will see that in the options, in all the options, E equal to minus of something is given. So this value of E0 cell we have to predict first. Now, if you see the half cell reaction that is mentioned to you in the question is of that of hydrogen electrode, right? So for hydrogen electrode, it is a standard hydrogen electrode, right? So for standard hydrogen electrode, the E0 cell value should be 0, correct? Because it's a reference electrode. So in this question, the E0 cell becomes 0, because of which you will see that in all the options, E cell equal to minus of something is given, as E0 cell becomes 0. Okay. Now, let us first write the equation. What is the equation suggesting? So H plus upon gaining an electron, that is upon reduction, is converting to half H2. Is that right? Now, for this reaction, for writing the E cell value, what would we do? We will be writing E cell equal to minus RT. Now, N is the number of electrons that has been lost or gained in a particular reaction. Now, in this case, we have gained 1 electron. So, it should be 1. So, since we do not write 1 anywhere and we consider it, we do not consider it at all, right? So, it is present, as if it is present. So, we are writing it as minus RT by F ln of, now how would we write the product? The product is H2. Right, students? Now H2 is a gas, so the concentration of any gas would be given in terms of its partial pressure. Now the pressure is already mentioned to you in the question. It was given P atmosphere, right? So we would write it is P of hydrogen, that is partial pressure of hydrogen gas, to the power of its coefficient here, divided by reactant would be H plus, that is concentration of H plus ion. So that should be the answer. So it matches with option number A. So your correct option would be option A. Am I clear? Now let's move on to the second question. So the next question is, let me read out the question. The standard reduction potentials of the elements P, Q, R and S are minus 1.36 volt, minus 0.32 volt, 0 volt and minus 1.26 volt respectively. The correct order of the reactivities would be, and there are again 4 options. Now this question is a very straight cut question, okay? If you know the concept once, you would be able to answer the question directly. So it says the P has a reduction potential of minus 1.36 volt. For Q it is minus 0.32 volt. Then for R it is 0, I believe. And for S it is minus 1.26 volt. Now the concept behind this question, or to solve this question, is the lower the value of reduction potential. I repeat, lower the value of reduction potential, greater is its tendency to get oxidized. That is, to get more reactive. So, lower the value of reduction potential, greater is its tendency to get oxidized. As a result, if a substance gets oxidized very easily, okay, then its reactivity should increase, or its reaction tendency should increase, right? Reactivity increases. So the lowest potential is for P, that right here. So P should be most reactive. Then the order would be S. Then the next would be Q, and then R. So this should be your order and your answer for this question. So this matches with the option C. So that would be your correct answer for this question. Now let's move on to the third question. The third question, before starting it, it's very conceptually very intriguing, and it is very interesting also. So a galvanic cell is based on the overall reaction. The reaction is mentioned to you, and for this cell, the E0 value is about 0.46 volts. That is a positive value. And if the molar concentration of Cu2 plus ions is made twice, then the value of E cell becomes. That's your question. Now, children, you have to understand this question very carefully. First, see, the question says that Cu solid has been changed to 2Ag plus aqueous. So the equation is already balanced for you to make it easier. So you don't have to balance. Now, in this case, I would tell you one thing, that if any equation is not balanced in electrochemistry, do not forget to balance it. Because if you do not balance the equation, you will not get the accurate answer. Clear? Okay. So the E0 cell value for this is mentioned as plus 0.46 volt. Right? Now, let us first write that the E cell value according to Nernst equation is E0 cell minus, let us consider it to be room temperature, that is 298 Kelvin. So for that, we can simplify the equation and write it as 0.059 by N log of product by reactant. So the product is Cu2 plus aqueous and divided by Ag plus whole square. Now, why have we not written Ag and Cu here? Because they are in the solid form, and in the solid form, we do not mention their concentration. We take it as unity. Alright, so this is our mother equation. Now, E0 cell is mentioned as 0.46, and that's a positive value. Right. So, and what would be the number of electron transfer? See, Cu to Cu2 plus, so it is a 2 electron transfer, so that becomes 0.059 by N log of Cu2 plus and Ag plus whole square. Right? Now the question says that the molar concentration of Cu2 plus ions has been doubled. In a reaction, the molar concentration of Cu2 plus ions will be doubled. Now, if the molar concentration of Cu2 plus ion gets doubled, so we can make it here 2, right? 2 Cu2 plus. Is it clear? Now, how will we change the equation? See, we can write this equation as E cell is equal to E or 0.46 instead of writing E0 cell a number of times. We can write it as minus 0.059 by 2, right? We can write as log of 2 and minus of 0.059 by 2 log of this part, the whole thing, Cu2 plus concentration divided by Ag plus concentration whole square. Why have I done it? Considering this part to be, this whole part to be B and this constant value to be A. So log of A into B should be log of A plus B. Now this factor 0.059 by 2 is multiplied by the whole thing. So we can write as log of A plus log of B. Now plus value would become minus since there is a minus sign in the beginning. Is it clear, students? Right. So now you see in this equation we have got two minus containing terms. So this is a modified form of the equation, right? So we can write it as E prime cell supposedly, right? Or take it as E1 cell, whatever you wish. Now see, if we compare E cell and E prime cell, what is the difference? See, 0.46 minus of this part is common in E cell as well, right? In this E cell equation, only this part is the additional part, right, students? So we can write E prime cell is basically E cell, the above E cell minus 0.059 by 2 log of 2, right? So on multiplying or on doubling the concentration of Cu2 plus, this new E prime cell has a value which is a reduced value because it has a minus containing term. So the value of the new E prime cell on doubling the concentration of Cu2 plus would be less than that of E cell, right? And that should be your answer. Just see which option it matches in the question. So it matches question the option number D. It would be, it gets reduced, right? Understood? Let's move to question 4 quickly. So question number 4 says, for an overall reaction occurring in a galvanic cell, E0 cell is found to be positive. For this reaction, you have 4 options. Which one should be the correct answer is your desired question. Now, this question or this kind of question is very common in your competitive examination because it just tests two concepts very clearly. One is your thermodynamic point of view and your electrochemistry point of view as well. So, it's mentioned that a given reaction has its E0 cell value to be positive, right? It's a positive value. Now, we know delta G 0, which is a measurement of the spontaneity of a reaction, whether a reaction will be spontaneous or not. What do you mean by spontaneous equation or reaction? Means whether it will at all occur or not, right? So it is written as minus NF E0 cell, right? Now if this E0 cell is said to be positive, then the whole value of delta G should be negative. Now from thermodynamics point of view, we know if delta G or Gibbs free energy is negative, then reaction is spontaneous. So the first option, first thing that we have calculated, that delta G should be less than 0, right? So first check which options it is matching. So you will see that it matches with C and D. So automatically your options A and B are eliminated. Now students, in competitive examinations, try to eliminate options as much as possible, because then only you can approach to the correct answer, right? So automatically we have removed 2 options. Now coming to K equilibrium. Now K equilibrium is the equilibrium constant. How is E0 cell related to it? We know minus NF E0 cell is equal to minus 2.303 RT log K equilibrium, right? So if we cancel out the minus from both sides, if E0 cell is positive, then K equilibrium should also be positive, right? So K equilibrium should be greater than 0. So now check which option is it. Or sorry, greater than 1, because obviously log of 0 would be 0, right? So K equilibrium cannot be 0. It should be greater than 1 at least. So it would be greater than 1. So it matches with the option C. That would be a correct option. This is a very common question. This equation and this equation is very frequently asked in your examination. So it is very important as for both your boards as well as your joint entrance examinations. So please mark these two equations very carefully. Coming to question number 5. See, the specific conductance and molar conductivity of a saturated solution of AgCl are given, assuming the specific conductance of water is negligible compared to that of the solution. The value of solubility is. Now, how would we solve this question? See, students, specific conductance is your kappa value. Now, kappa of any salt solution is equal to the conductance of the salt along with water. Conductance of water. Because we are dissolving the salt in water, then only we will get a salt solution. So, this should be the equation. Now, it is specifically mentioned that the specific conductance of water is negligible. So, we'll consider this to be 0, right? So, this is mentioned, the specific conductance of the salt is mentioned as 1.84 into 10 to the power of minus 6 ohm inverse centimeter inverse, right? Now, in electrochemistry, another thing you have to keep in mind is the units very carefully. Alright, so we know molar conductivity chi m is equal to kappa by C. Now, we can replace C as solubility as well, S, which is asked in our question. Now, substituting the values for solubility would be kappa by chi m. So, kappa is given as 1.84 into 10 to the power minus 6 ohm inverse centimeter inverse. And you have chi m as 138.6. Okay, 136.8. I'm sorry. Ohm inverse Siemens square and mole inverse. Right, students? Now, if you see, the units mentioned in your answers is mole liter inverse, which is your molarity term, right? So, first of all, just see that centimeter square is there and centimeter minus 1 is there. So, if I take this centimeter upwards, we would get centimeter minus 3. Right, students? Now, ohm inverse and this ohm inverse will cancel and mole would go upwards and form mole minus 1 would be mole. So, we get mole centimeter minus 3, right? Now, this part, if we solve, we'll be getting 1.84 into 10 to the power minus 6. Right? Students, divided by 136.8 would give us 1.34 into 10 to the power of minus 8. Now, we have to change it into mole per liter, right? Now, you know 1 liter equal to 1000 cc or 1000 centimeter cube. Right? Right? So, this is actually what? This answer is, if I write it, mole per centimeter cube, this is it. Right? So, to convert it to liters, we have to divide centimeter cube by 1000. That is when we get liter. Right? So, this divided by 1000 would go up. Yes or no? This divided by 1000 would go up and it would become what? 1.34 into 10 to the power minus 8 into 10 to the power 3. Correct? So, this would be 10 to the power of minus 5 and you would get your unit as mole per liter. So, your answer will be 1.34 into 10 to the power minus 5, which matches your option B very clearly. There's just very little difference because they have used the correct exact value from the calculator. That is why they have got 1.345, which you have got in nearest result. So, that is your correct answer. Clear, students? Coming to the last question of today's discussion. See, the question says that it's a cell reaction given or a cell notation given to us with the E cell value and the reduction value for Fe2 plus 2Fe and the reduction value for Cu2 plus 2Cu. So, first let us write down the cell notation that is specifically mentioned to us as FeS, Fe2 plus, given as X molar, right? And we have Cu2 plus to, which is a 0.01 molar solution, to Cu solid, right? And the E cell is mentioned as 0.78 volts, and the individual reduction potentials are given, which we shall discuss a little later. But first things first, students, whenever you see a kind of concentration value given to you, the first thing that should strike your mind is that you have to use the Nernst equation somehow. So that is a clue. Alright. Now, the left hand side of any cell equation denotes the anode part where oxidation occurs. Right? And the right hand side denotes the cathode part for any galvanic cell, that is. And it denotes the reduction part. Right so far? So, now to calculate the E0 cell, we know E0 cell is equal to E oxidation plus E reduction. Now, oxidation is of Fe to Fe2 plus, but then the value mentioned to you is E0 of Fe2 plus to Fe is given to you as minus 0.44. Now, if E0 of Fe2 plus to Fe is given as minus 0.44, so this is the reduction, right? Now, it is actually oxidation that is occurring, so the oxidation value will be reverse of this, so this should be plus 0.44 volt. And in your question, the reduction value of Cu2 plus to Cu is given, and in the cell notation also it is reduction only for copper. So we don't have to change that value, which is written as 0.34 volts. So we shall happily substitute that value. So what will we get? This should come out to be 0.78 volt. Right, students? Okay. Now applying Nernst equation, since concentrations are mentioned. So E cell would be equal to E0 cell, which is 0.78 volt, considering it to be at 298 Kelvin, since nothing is mentioned. So we can take that assumption for sure. So we'll write it as by N. So in the mother equation, Fe2 plus would be a 2-electron system, and reduction of Cu2 plus to Cu would be also a 2-electron system. So it's a 2-electron transfer reaction. Log of product will be Cu2 plus, right? Or rather, let us just write the equations separately so that it becomes easier for you. So Fe minus 2 electrons would be Fe2 plus, and Cu2 plus 2 electrons would be Cu, right? So cancelling out the equations, we get Fe plus Cu2 plus gives Cu plus Fe2 plus. Is that right? So the product side would be concentration of Fe2 plus, right, students? And the denominator would be the reactant side Cu2 plus. Now, why have we not taken only copper and iron? Because they are solids, so we are going to consider it to be unity, right? So the E cell also is mentioned to you, correct? It was mentioned in the question. I have written it, I think, in the solution part. Let's just check. Yes, the E cell was 0.78 volts, right? So 0.78 equal to 0.78 minus 0.059 by N. Log of Fe2 plus is not there, so it is mentioned as X, but Cu2 plus is given as 0.01. Right, students? Now you see this part gets cancelled out. So we can write that 1 equal to minus 0.059 by 2 log of how would we write it? This is log of A by B, right, students? So we can write as okay, just don't make any confusions like that. Just keep it that way. Okay. Now what will we do? Now we will do is this part we will. Okay, now students, 1 second. I've made a mistake here. That if this cancels out, so we would get a 0 this side, right? So okay. Now multiplying it with 0 and dividing it by 0 gives nothing. It's the same thing, right? So we would be getting a 0 this side, right? So log of X by 0.01. Using anti-log on both sides, what would we get? Anti-log of 0 would be 1. And anti-log of a log would be X by 0.01. So X will come out to be 0.01 molar. That's your answer. It matches with option number A. So that should be the correct answer. So here we come to solving about 6 questions, I believe, of electrochemistry chapter. And each of the 6 questions are absolutely different in terms of approach and in terms of concept, but they are interlinked in terms of formula, right? So we are going to so your homework is to revise those formulas, try to do these questions on your own and see whether you can do it. And if you have any other queries of any question from this chapter which you have solved maybe at home, you can always drop it down in the comment section below. Also, if you have any queries regarding the process that I have solved a question here, and if you have any other suggestions that or any other process to solve this question, the same question, that is also most welcome in the comment section. So in the next video, we shall be discussing about some other new chapter which will be helpful for your upcoming exams. Till then, stay safe and keep revising.